Okay. Question number 11. So, let's have a look at the question, because one of the worst things people do when there's a picture, a graph, a diagram is they assume that this text must be irrelevant and jump straight to the picture, the diagram, or the graph. So, use the graph. So we're actually going to need to use this graph to change 21 feet into meters. So we're going to need to change 21 feet into meters. So we're going from feet to meters. All these little things like highlighting or those arrows are just to show I don't make a silly mistake like go the wrong way, do the wrong thing. So we need to find 21 feet. This is the feet on this y-axis, and it's going up in fives, but what is really useful is to work out early on what does each one of these little squares actually represent. Here, there are 5 squares going up to 5, so it's really easy. Each one of them represents 2. You don't need to write all the numbers on, but it's worth acknowledging, especially as the x-axis may not be the same as the y. So, if I want 21 feet, and these are going up in ones, 5, 10, 15, 20, 21 feet is there. Now it says use the graph because your working out is now your ruler. You will use a pencil, obviously I'll just use this thick green pen so it stands out. 2 hands, 21, get it please, so it's on that horizontal, super carefully lined up, and draw a horizontal line, your working out line, until you meet the graph's line. So I've drawn a line from 21 to there. This is my working out. I'm being really accurate, because if I move 1 mil up or down, I'm changing my answer, and it might be that you're changing it outside the tolerance. And where I hit that line, I'm going to drop in a vertical. Now, it looks like I hit it bang on that vertical line there, so that's nice. I can just go straight down there to that point there. So now I've got that point there, I need to look at the x-axis and see what is the scale, because it looks different to the y-axis. Here, I'm going up in 2s, but each 2 is worth 2 boxes, so actually, that is 1, 3, 5, and 7, and to get between each of these, it's now a jump of 2.2, 2.4, 2.6, 2.83, so it's going up in 0.2s. So if I look here now, 6, 6.2, 6.4. So 6.4, and it's meters. So I've done my working out lines, I've checked both scales, and I've got an answer. Okay, it now tells you something about somebody else. It says Adam's height is 5.5 feet. Use the graph. So again, we're using the graph. We're going to put in a working outline in to work out Adam's height, and key word there is in centimetres. So, Adam's height is 5.5 feet. Let's go back to our graph. If we're saying these are going up in ones, that's 5. The next line is 6. 5.5 is halfway up that square. So we're going to have to be even more careful now because we're not following a line. We're following halfway between that line. So, worth looking a couple of times, eyeing it up and getting halfway along. And then a horizontal line, halfway along, until I hit our graph line. When I hit our graph line, as before, we drop a vertical down. This one looks like it's going halfway between the boxes again, so I need to be really accurate. Biggest mistake I see here is people think, oh, it's nearly on that line, I'll just join up with that line. It's not on that line, it's to the right of it, so be super accurate. So, if these are going up in 2s, 1.2, 1.4, 1.6, 1.8, it's bigger than 1.6. It doesn't quite look like it's in the middle in 1.7, so it looks like it's 1.65. So it looks like 5.5 feet equals 1.65 meters. I'm writing that down because then I remember I need to change to centimeters. To change to centimetres, I acknowledge that there are 100 centimetres in a metre. So I do 1.65 times by 100, which gets me 165 centimetres. Marks here. That was a 1 marker. So it's just the answer. You get a tiny bit of tolerance, but you need a sharp pencil and you need to be super accurate. Here, it was worth 3 marks. Acknowledging that you get 1.65 metres. Acknowledging that you need to times it by 100. Final answer. So whilst a lot of us could have done that in our heads or on a calculator, can you notice that because it was 3 marks, I wrote it down? Even though you may well have just done it in your calculator and you may well know that 100 centimetres in a metre. Because it was 3 marks, I've made sure I've got enough work to justify it. Before you turn over, pertinent videos. 151, 152. They're both on graphs. They're both specifically on conversion graphs. The first one, though, is to do with drawing. The second one is to do with interpreting. So just like with the pie chart videos, there's a specific video for drawing, and then there's a specific separate video for the interpreting, the reading of the graph. Right, that was question 11.